So today we're going to do the 2019 question. So we just take a look at the question. The image on the right shows a modern penny bicycle. The front wheel has a radius of 350 millimeters. That's going to be important. The wheel is shown below. The spokes are at 30-degree intervals. That's another important principle here. Reflector, as shown, is located on one of the spokes at a height of 220 millimeters. The wheel rolls along the horizontal line AB, so we'll mark that in. AB, like so. And plot the locus of the reflector for full 1 clockwise rotation or revolution of the wheel. Okay, so the first step we're going to do, because it says the spokes are 30-degree intervals, divide up our circle, which is already drawn, into 30-degree intervals. So use your 60-30 set square. Very easy. Crosses out. And we're missing one. So this one. So that divides our circle up into 12 different sections. So we just label them. So that could be 0 or 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and back to 12. The second part, what we do is mark in the reflector. So it's up to 120 millimeters on this spoke. So I have that marked in earlier on. So I'll just mark in the point. So that's where we're going to plot our locus from. Okay, so then the next step is we have to draw a parallel line to AB. Okay, so we can use our fine liners again, just for clarity. Okay, so this is from the center of the circle. Okay, so line any length out there. Okay, so on this line we have to represent the circumference of our circle. So how we do this is we get, these are all equal distances from 1 to 2, 2 to 3, 3 to 4, 4 to 5. So we can take any of these distances. So I'll take this distance, then you plot your 12 distances. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so next step is to bring them points down perpendicular to AB. So pretty simple. Set square again. These are all basic stuff so far. You're gaining marks as you go along though. Okay, so you should be trying to keep it as neat as possible. Okay, so it's important to label also. So we label these points. We'll just get another we can use any color, doesn't matter. So label these. So C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, C12. So how we're going to plot our locus, we're going to use the triangulation method. So we have been through this before, another key principle, but we'll go through it again. So I'm going to pick a random point just for the first one, and then we'll go in order. Okay, so say 0.7. So we'll take 0.7, get another fine liner. So plot the triangle. So from your point, bring a line to 0.7. Okay, bring a line back to your center and back out with your radius. Okay, so that's your triangle that you're going to plot. So we have our radius from 7 to center. Okay, so we go to 7 on this one. So this is going to be our radius. Okay, then put our compass on the point, like so. Compass on the point, and put it to 0.7. Put on the bottom, on line AB, swing an arc. Yeah, swing that arc, make sure you have your compass in the right place. Okay, and this distance from the center to the point is your next part. So put it on top of C7. Okay. So that's going to be a point on our locus. Mark that in. So triangulation, the triangle corresponds to here, like so. Okay, so that's the principle of triangulation. So you continue on. You do that for each point. I'll do it for one more point. It's important also to know that a straight line here won't create a triangle. So all you do is go from point 4 back to your point P here. Get that distance. Place it on point 4 here. Go straight up. And that's going to be another point on your locus. So you continue on, use your triangulation method, and you'll plot a locus. Here's one I did earlier. So the locus is going to follow this line, like so. See all the points that I've plotted? Okay, when it hits here, it's going to go out a bit. Okay, so that's a trochoid, an inferior trochoid. It's inferior because your point is inside the circle.